Good morning students. In today's class we are going to learn module 2 linear filtering methods based on DFT and FFT algorithms. So this particular module will teach you how to go with linear filtering methods such as overlap add method and overlap save method and also FFT algorithms. So what are the topics we are going to learn here is, as I told, filtering of long data sequences such as overlap add method and overlap save method. So this particular filtering, it is applicable if there are two sequences where you need to find the linear convolution between those two. In that, one sequence will be of long duration sequence and the other one is of short duration sequence. If that is the case, direct linear convolution formula cannot be used. So we can go with these two filtering methods, which is also used to find the linear convolution between those two datas. So one method, such methods are overlap add method and overlap save method. Apart from that, you'll be learning what is fast Fourier transform algorithm, which is also known as FFT algorithm, and we'll be finding out what are the efficient computation of the DFT and radix to FFT algorithms for the computation of DFT and IDFT. And such algorithms are decimation in time algorithm and decimation in frequency algorithm. So both of these algorithms are used to compute DFT and IDFT of a sequence. So as I told, we'll be using this linear filtering methods provided one sequence will be of short duration and whereas the other sequence will be of long duration sequence such as hundreds of samples. In such cases, it is uneconomical in terms of computing time and storage to use the same length of transform for both x of n and h of n. So in those cases, in real-time operations or applications, the use of very long transform length for x of n may give rise to unacceptable processing delay. So in order to overcome this, we'll be going with two such algorithms called as overlap add method and overlap save method, where we'll be using the fast convolution method in order to find the linear convolution between those two. So as I told, these are the two commonly used techniques, overlap add method and overlap save method. So let us consider two sequences x of n and h of n whose length is k by n and m respectively, where k being the very large integer. So now the sequence x of n, we are going to divide it each of length capital N. So what is the objective of this method? As I told, it is to find the linear convolution between x of n and h of n, and the output sequence is named as y of n. Hence the objective is represented as y of n is equal to x of n convolute h of n. So what is the procedure for the overlap add method? So first I am going to tell you what is the procedure to convolute using overlap add method. So the first step is that you need to find what is the value of capital N, M, L, okay, and whereas N represents the number of samples to be divided with respect to x of n. So whatever the given long duration sequence x of n, you need to divide it, that is you need to segregate in terms of capital N. So for example, if n is equal to 5, you have to segregate it as 5, 5, 5. And whereas m represents the length of h of n and L is equal to 2 power of m. So this particular formula L, it is nothing but the block length, or it can be taken as number of points for which the DFTs are going to be computed. So we have another formula for L as n plus m minus 1. So the first step, as I told, you need to find capital N, that is the number of samples which to be divided with respect to x of n. M represents the length of h of n, and L we have block length, and we have two formulas, 2 power of m, or otherwise you can use n plus m minus 1. So the second step is you need to form the sequences h dash of n, x1 dash of n, x2 dash of n. And what is h dash of n? So h dash of n is computed by zero padding the sequence so that the entire length becomes capital L. So what you need to do is take down the sequence h of n as shown in the block there and then add some zeros. So how many zeros you need to add is, so based on the capital L. Suppose L is equal to 5 means, whereas h of n is 3 means you need to add 2 zeros at the end. And x1 dash of n also can be calculated such that first we'll segregate the entire x of n as x1 of n, x2 of n, x3 and so on. Okay, so this x1, x2, x3 is segregated with respect to the value capital N. Okay, and then we will frame x1 dash of n such that we'll take down the sequence x1 of n and we'll be adding zeros at the end so that the entire length becomes equal to L. In the same way you need to do for x2 dash of n, x3 dash of n, x4 and so on based on the length of x of n given. See, this is what it is shown in the first figure. So take down the given x of n, x1 of n as such and add m minus 1 zeros so that the entire length becomes L. The same way you need to do for x2 of n, x3 of n and so on. So step 3 is that you need to compute the product of x1 dash of n circular convolute h dash of n. So you have to find out y1 of n, which is nothing but taking the circular convolution between this x1 dash of n with h dash of n. Then again you find out y2 of n, which is equal to x2 dash of n circular convolute h dash of n. In the similar way you need to do it till complete x of n is done. And similarly you can name the products as y1 of n, y2 of n, y3 of n and y4 and so on. So what is step 4? So step 4 is that you need to shift each data, each output starting from y2 of n to produce y2 of n minus capital N. That is, you need to shift the sequence y2 of n by a amount of capital N towards the right hand side, so that you will be getting y2 of n minus n. And for y3 of n you have to make a time shift towards the right hand side so that you can produce y3 of n minus 2 times of n. So in the same way you need to do for y4 of n. So y4 of n will be obtained by taking time shifting to produce y3 of n minus 3 times of n. So in this way you need to time shift the sequences leaving y1 of n. So and finally the output y of n will be computing it using the formula y of n is equal to y1 of n plus y2 of n minus n plus y3 of n minus 2n plus y4 of n minus 3n and so on. This is how we are getting the linear convoluted output y of n. So once again I'll repeat the procedure. So for the overlap add method, the intention is to find the linear convolution between two different sequences x of n and h of n, where x of n will be of long duration sequence and h of n is a short duration sequence. The procedure is, first you need to calculate what is the value of capital N, M and L. So n is taken as the number of samples which we are going to divide with respect to x of n given, and m as usual it is length of h of n, and capital L represents the block length or number of points for which the circular convolution we are going to compute it. So L has got some two formulas, 2 power of m and or L is equal to n plus m minus 1. Any one of the formula you can use it. If n value is not given, you can make use of 2 power of m. Suppose if n value is given, you can use the formula L is equal to n plus m minus 1 to calculate L. Okay, so the second step, as I told, you need to calculate h dash of n, x1 dash of n, x2 dash of n. So how to obtain this h dash of n is, take down the sequence h of n given as such and add zeros at the end so that the entire length becomes the block length L. In the same way you need to take x1 of n, x2 of n, x3 of n after dividing it into different blocks using capital N. So for that x1 of n you need to add zeros at the end so that the entire block length becomes L. In the same way you need to do for x2 of n, x3 of n till the sequence ends. So step 3 is such that you need to compute the product y1 of n, y2 of n, y3 of n by taking circular convolution between x1 dash of n and h dash of n. For y2 it is circular convolution between x2 dash of n and h dash of n. So step 4 is you need to make a time shifting towards right for y2 of n as y2 of n minus n, and for y3 of n minus 2n, and so on. So finally you will be getting the output if we are going to add this outputs y1 of n plus y2 of n, this shifted outputs y1 of n plus y2 of n minus n plus y3 of n minus 2n plus y4 of n minus 3n, like that it will go on. So this final output you can name it as y of n, which is nothing but the linear convoluted output between x of n and h of n. So let us continue in the next video. So in the next class we'll be solving the problems based on this overlap add method. Thank you.